Good morning, good afternoon, or good evening, everyone, depending upon where you're at in the world. Thank you for joining us today for our AI Threat Landscape webinar. It's our second annual report. We've got a lot of useful and exciting information and excited to start diving into it with all of you. So again, you can see the agenda here on the right. We're going to go through a wide variety of things. And why don't we go ahead? We're going to launch a little bit of a survey. Live polling. So we'll do that here in a second as well. So be prepared to answer a couple questions. And why don't we just jump straight in and do a little bit of intros for our panelists here that are part of the HiddenLayer team. So I'm Chief Security and Trust Officer with HiddenLayer. We've got Tom, who's our Senior Vice President of Research, Eoin, who's our Director of Threat Intelligence, and Marta, who's one of our Principal Security Researchers. So they're the brains of this, and I'm the moderator. And I think, again, as I said, you're going to enjoy this, and I think walk away with a lot of great and useful information for you. So again, why don't we go ahead and transition to some of the polling questions. All right, looks like we're starting to get some of those things in here. We'll circle back to that in a minute, but again, I think we've got a wide variety of responses and answers here that give us a good mixture of people's perspective around the things that they're saying and doing. Again, I appreciate everybody who's responded to that. Along the way, if you have questions or comments, there's a QA button. Please use that. Towards the end, we're going to try and save 10 or 15 minutes, and so we will be leveraging the questions that people have put in, the comments that they have that they'd like us to respond to as a part of the dialogue here today. All right, why don't we go ahead and go into a little bit more of the actual survey questions. All right. So we did a survey, a couple hundred people, 250 people around the world, director level and above, mixture of CIOs, CTOs, data scientists, security folks. Again, I think there's a few key messages out of that survey data. AI is critical to business success. We found that 89% of folks indicated that it's mission or business critical to their organization. So again, if you think about it, if it's mission critical, if it's compromised, there's a material impact to your business. Risks are rising. 74% of folks have indicated some level of AI-related breach or incident that they have experienced. 45% has been because of malware in models that they got from public repositories. And again, we'll go into a little bit more detail on that. But again, pretty interesting findings. And then there's some in essence, debates and gaps that people have reported in their overall corporate governance, as well as in their technical controls. 76% of people, so 3/4 of us, have said that there's still a debate. Who owns it? Security team, IT team, data science team. Well, okay, those type of governance things obviously leave room for challenges and problems and decision making, which again contributes to risk. I think the other thing that it contributes to, and again, we found this on the technical side, only 32% have said at this point that they've deployed security technologies to manage and mitigate the risk, which is important because we know and we've experienced, and I think most people would understand, that their existing security stack doesn't manage and mitigate the risks specific to AI models and AI systems. So again, that's an area that needs to be focused on. Now, some hopeful things in terms of where to focus. If we go to the next slide here on again, a couple other survey points, we found that 95% of people have indicated they're increasing their budgets for security and AI in 2025. Again, makes sense. We just have started this evolution the past couple of years, and sometimes it takes a little bit of time as people have experimented to get budgets aligned and start properly addressing the risk. So that's good news. And 99% of folks consider securing AI a high priority, which again also makes sense, considering the vast majority of the AI models used in organizations are mission and business critical. So, with that, why don't we go ahead and start transitioning into some of the deeper aspects of the research that we've got. And, Eoin, I know you're gonna, talk about with us what's new in AI, but maybe one of the things that you can also talk about is what are some of the biggest trends, right, that we've seen in 2024 and going into 2025.
Yeah, thanks, Malcolm. Absolutely. So the big trends that we've seen, and I will call them big trends, keeping up with AI is a full-time job, and you can take our word from that. But the big trends that we've seen is that we've seen a shift from kind of traditional models, which maybe take one particular type of input and provide you the exact same type of output, to a more kind of multimodal approach, where models are now able to handle images, text, audio, and start to kind of coalesce and understand the contextual meaning between these different inputs. And then as a result, provide you more outputs that transcend the modality that maybe have initially intended. So that has really paved the way into the agentic conversation. Agentic is, I guess, what does that mean? Agentic AI systems are essentially systems that we've imbued with agency. So the ability to perform actions on our behalf, to kind of, reason on data and perform more complicated chains of actions that may interact with, functions, plugins, systems, APIs, or whatnot. And we've started to see the first glimmers of these agentic solutions in things like, OpenAI's Operator. Anthropic has computer use as well. And these are, tools or systems that enable LLMs to interact with the desktop. And that's, quite interesting because, it usually would have taken a lot of reinforcement learning or a human being in front of the computer to be able to click on things, to bypass those like pesky captchas that you have to try and select 6 cars in a 9-car image or what have you. And these things are starting to do that with surprising ease and capability. So again, the way I always look at AI is, while we've come so far, we still have so much further to go. So what we see today, while we may think it's advanced, in a few years' time, that's going to be, old technology. And if we look back even at the last year, 2, 3 years, we've seen, major shifts. And Tom and I were even chatting just this morning at how much the space has really redefined itself. So, some other big trends is, fine tuning was a large part of how people made LLMs more applicable to their target domains. And that was, quite useful. However, what you end up having is more overhead in terms of cost to retrain. You need more maybe GPUs to do this fine-tuning process. And it just wasn't fantastic for keeping your documents that we're using with your LLM up to date. So we've seen a big trend in terms of AI deployments now leveraging retrieval augmented generation, or RAG systems. RAG systems are essentially a way of taking documents that you have or information that you have, putting it into an embeddings DB or a vector DB, and then having the LLM augment its prompt based off of the kind of bits and pieces of all these documents, meaning it can retrieve information pretty much in real time from your document store that you've kind of pre-populated for the model to access. So this has meant that enterprises can now actually, leverage the full breadth of their, Google Docs or their Confluence pages and any other documentation that they may have in various amount of different services or tooling, and have it all in one accessible place.
Hey, Owen, kind of related to what's new, and then also into thinking about the risks related to the use of AI that we'll go into next. What's the shift from safety to AI security that we've seen? And I think that then will lead us into really the risk related to the use of AI on the next slide.
Yeah, absolutely. So the big thing here is, we've seen places like the AI Safety Institute in the UK renamed the AI Security Institute. Security has now become the major focus across the world. And I think it comes down to one main reason, insofar that, efforts to provide more safe AI systems is undermined if the security of those systems is not there or present. So ultimately, I think the way of envisaging this is that security has to be that base foundational layer that we then go and build upon to ensure that systems are safe. I mean, if we spend a lot of time and money in terms of alignment, but then we can bypass all that alignment through prompt injection, we then end up in a quite a difficult situation.
No, I think you're totally right. Again, it's you have to have the safety things, but unless you have the foundation of security protecting the safety mechanisms, you don't end up resulting in having safe systems. Why don't you dive into further then the risks related to the use of AI that we've seen over the past year?
Yeah, absolutely. So the risk related to the use of AI has been quite interesting. We've talked about deep fakes for quite some time now, and we're seeing these being used quite at large scale. We've seen CEOs and CTOs be targeted. There was an example of a bank in Hong Kong that ended up getting scammed to the tune of nearly $35 million by impersonating their CTO. And we see, again here with the CEO of a large ad firm. We've seen kind of a trend as well for threat actors to start leveraging LLMs in the generation of, I guess, what we would kind of typically have referred to as polymorphic malware, except now they're using AI to generate bits and pieces of malware inside executables, which is quite interesting. Aside from just the fact of leveraging it to create malware and phishing campaigns wholesale with quite some ease. We're seeing, disinformation at quite a large scale as well. We've just gone through an election cycle in the US, and we are in a number of other countries. That's been quite interesting. But one of the examples that isn't actually spoken about here that I really thought was interesting is the use of deepfakes in election campaigns. So that when, you might be a willing voter looking to determine who you vote for in the next election, and you get a phone call from that candidate with their voice convincing you to vote for them. And this is like, we're going to start to see incredibly targeted phishing campaigns done en masse, automatically, leveraging the voices of the people that you see on the TV day to day. And I think that's going to really basically bend the fabric of reality and make it difficult to perceive fact or fiction. Apple Intelligence was rolled out recently on iPhones in the US, unfortunately not in the EU for some of us. However, what we ended up seeing there was that summaries of news articles were starting to be misrepresented. And we saw this with one particular high-profile case with Luigi Mangione and unfortunately, and God rest him, the CEO of United Healthcare, where it was misreporting the evidence of the case to users across the US. Additionally from this, we're seeing people misuse AI, unfortunately, in like Zoom settings, where you may have a video call that is transcribing your entire call. Somebody may be asked to leave and perhaps a job interview, and then the transcript of said call is then emailed out to all constituent members of that call. So we're seeing kind of this little bit of friction in terms of how AI systems are being deployed in the workplace, because they're leading to blind spots and potential confidentiality breaches along the way that makes it difficult to understand where exactly our data is going. Finally, and quite unfortunately, we also saw an incident where quite a young individual ended up committing suicide, unfortunately, after basically forming quite an attachment to an AI model. And this led to, ultimately an incredibly unfortunate situation. Following that, a lawsuit as well against the model provider. But I think it speaks to the power of, these models that to form, connections with individuals, and the responsibility thereof of us in the industry to ensure that, these models are going to hopefully, have our best interest at heart to the best of the ability that we can. And ultimately, this highlights that there's a lot of risks related to the use of AI, but ultimately there's also quite another side to that coin in the risks posed by AI systems. And for that, Malcolm, happy to pass back to you. And
and I think you mentioned some really good points, and I think it's all important for all of us to recognize. Again, there's the business impact of these things, but then there's also a societal human impact, depending upon the the use of the AI and who is benefiting from it or at risk because of it. Why don't we transition on? Marta's going to go through and give us some perspective on the risks faced by AI systems themselves. So not just the use, but the actual risk specific to AI systems.
Yes. So last year we were talking mainly about things like data poisoning or inference attacks, which can result in model evasion or model theft. This year, the scope of attacks expanded very much, also because we faced the emergence of new technologies and what comes with it, new attack vectors as well. So the old techniques, the existing techniques of data poisoning and model evasion, they got significantly advanced over the past 12 months. But what's most important here is the very new, brand new techniques that were discovered of attacking AI in many different ways. So one of the coolest discoveries, I would say, of the 2024 is the architectural backdoors. We were mentioning model backdooring last year as well, but we were talking about different kind of payloads. So we were talking on two levels. One was the supply chain attacks, in which serialization vulnerabilities in model serialization formats were used to execute arbitrary code, leading to more traditional kind of breach, like malicious code execution on the victim's machine. And neural backdoors, so injecting different logic into a machine learning model, into its weights and biases. This year, last year, we uncovered, our researchers uncovered a novel technique of injecting a logic backdoor into a machine learning model. And this technique depends on adding instructions into the architectural graph of the model. So many models are shipped, are saved in formats that include this computational graph, which is basically the model architecture. This graph specifies all the instructions or operations that will be executed upon the model loading into memory. And those are a bit different from normal code execution. So binaries, executable files, they use assembly language instruction to actually execute actions. But in machine learning models, those instructions are of a different kind. They are related to machine learning operations. But on some level, those two executable files and the machine learning models are similar in the way in which they actually operate. So
Marta, I'm just going to interrupt you real quick and ask Tom a question. Tom, with what Marta said, what industries, what verticals, what could be the really, who gives a crap about this? What really should a head of security, a chief privacy officer, chief compliance officer worry about that type of backdooring and what it could do to their business or their customers?
Yeah, good question. I mean, I think anywhere that consumes third-party models, really, whether you're getting those from sort of public places such as Hugging Face, or you're relying on third parties to train those and deliver them to you, any part of sort of the classification or generation portion of the model can be subverted. So, if that's like security solutions, it's easy to implement a backdoor that would bypass security controls. That could be, anti-malware scanners. It could be, I don't know, sort of X-ray solutions or CCTV solutions, that sort of thing. Also generative AI as well. So we can put backdoors into models that would deliver biased or harmful or misinformation in response to certain keyword triggers. And these things are very, very, they're very easy to embed in the model from our perspective. They're incredibly hard to spot and detect, and then determine how you trigger them.
Exactly. So Eoin, kind of related to that, you and I have had this dialogue in the past, right? If I can make a German Shepherd look like a Pomeranian, or if I could hold up a cup and disappear, again, what would be the implications of that, let's say in the travel industry or in border protection or something like that? Sure.
Yeah, no, great question. There's a few different use cases there. I mean, if we're taking a border protection aspect to it, I think, for many of you who've traveled in and out of the US, maybe as frequently as I have, you end up getting facially recognized quite easily. However, if we ended up with a subverted model in one of those aspects, we could maybe potentially include a trigger in the face. Maybe it's a certain connection of moles, maybe it's a necklace, maybe it's a gold tooth or something of the sort. And maybe that triggers a misclassification of a different individual that we then can leverage to bypass that model. That's
so
hypothetical.
Malcolm could be a terrorist and walk straight through the front door because I happen to have a gold tooth, or my button over here is blue instead of white.
Right, exactly. And I think, extending that out into other applications like the financial industry, it could be something like a loan approval, disregarding any of the, preconditions that have been placed on the model. It could be something perhaps in a military application with, geospatial looking of observability of troop movements. For instance, there's real applications that are quite broad spectrum here that ultimately, as Tom said, if it really is quite a general solution, or not even solution, quite a general problem, if forgive me, that could affect pretty much any model of any application as long as it has a graph representation.
Okay, awesome. Thank you. Hey, Marta, back to you. I'll let you drive through some more of this stuff.
So besides the model backdooring, which is one of the coolest techniques that I saw this year, there is also a big shift in the techniques of attacking generative AI models. So last year we were talking already about prompt injection techniques, but this year this evolved into indirect prompt injection. So with multimodal models, like Owen mentioned before, models that can process not only text, but different kind of inputs like images, files, PDFs, for example, URLs, and so on. There is another new attack vector opening. So the attackers don't really have to have direct access to the attacked AI anymore. They don't have to access to the chatbot itself in order to prompt inject it. They can create a malicious document or trick user to click into a malicious link, and those resources can contain hidden instructions for the chatbot. So with solutions like a Gemini workspace or cloud computer use that have access to different kind of modalities, different kind of inputs, the attackers could actually indirectly inject prompts into those chatbots that interpret this data, and could, for example, exfiltrate sensitive data or force the model to return specific outputs, for example, to make disinformation campaigns or propagate spam or and so on. We have a couple of blog posts on this topic, so if you're interested, please visit our website to read more about it. But our researchers were able to, for example, create malicious document which would force Google Gemini to display spam links to its users. There is also the watermarking issue. So lots of generative AI right now watermarks, for example, their images. So to be able to distinguish if the image was generated by AI or it was taken by a photographer, for example. But unfortunately, there are techniques to bypass that as well. So it's possible to remove those watermarks. It's possible to change them with different watermarks. There is a lot of possibilities there as well. So we are definitely going in the right direction with the security initiatives here. So watermarking might be really helpful in combating deepfakes, but at this stage is still very prone to attacks and prone to actually overriding. Besides,
a question that typically comes up with folks in terms of the risk faced by AI systems, the difference between open source codes versus open source weights. How does that, play into the various risks faced by the AI systems?
So yes, there was a lot of news around the DeepSeek models, which are open weights models. The difference between closed weights model is that the closed weights model, we can query it. We have access. The user has access to its inputs and outputs, so can use it through an interface, but doesn't see the underlying mechanism, doesn't see the underlying files. Now, with open weights models, those files, those weights and biases of the model are made available to the user. And that might help the user actually implement such models in their environment locally without the need to use an interface provided by the model developer. And that can help also with fine-tuning those models locally by the user. And the thing here is that
depending upon, I mean, the growth in open source here, I think that we've got on the next slide just really further illustrates what you were just chatting about, right?
Yes. Yeah, right now, about 97% of companies that we surveyed say that they use some kind of pre-trained models, so open weight models that are accessible through portals such as Hugging Face. There comes a risk with that, obviously. So Hugging Face grew really fast over the last year. It's right now contains like 1.5 million repositories. And we did some statistics on how the models are stored in Hugging Face, which file formats are most popular for the pre-trained models. Since last year, there were some improvements. So lots of models right now are provided in the safe tensors format, which is more or less, more safe than other formats. But there is still a large chunk of models that are provided in the most unsafe file format, which is PyTorch or Pico. Those formats, those models can be easily hijacked to inject arbitrary code. Although users usually right now have a choice between downloading a model in safe tensors format or the same model saved as PyTorch, many users will stick with the formats that they know. PyTorch was around for a long while, and engineers have some habits that die hard. So that's still a bit of a problem there. So here we are facing supply chain attacks with the use of hijacked models, which are happening more and more often this year. Talking also about supply chain attacks, it's not just the models, it's the whole AI ecosystem, the whole AI supply chain, all the parts of it that can be attacked and used as a foothold, or as an initial vector of attack in huge and very devastating attacks. So this year there was the end of last year. The Ultralytics package was compromised. It was not a model itself. There were some libraries related to the vision recognition model that is vision recognition platform that is really very widely used across many industries. One of those libraries was replaced with a coin miner, a malicious coin miner that when the user installed this software on their computer, the coin miner was stealing basically their GPU power for their own purposes. So this could have been anything. It was just a coin miner, so it was not too devastating, but it could have been a ransomware or a backdoor stealing sensitive information. Could have been any kind of malicious.
I think you make a great point, Marta, in what you've shared here. Again, you look at 1.5 million models on Hugging Face. A lot of people downloading from them or other folks. You know, the risk of open weights and open source stuff, but 40% with unsafe model formats. We've got reporting 45% of the issues people have seen were malware embedded in it. And then the Ultralytics thing, as you mentioned, again, very prolific across a wide variety of industries. And the fact that while it was a coin miner and you go, okay, well, it chewed up some unused compute capacity, didn't really damage me. The potential for that to have actually done something else that would have taken offline, created an availability risk, a ransomware issue, some other type of pivot point of exploitability in your enterprise is enormous. Hey, why don't we transition now and start, talking about, some of the advancements in security for AI. So, Tom, why don't you walk us through, some of the things that we've seen in terms of really kind of the future and where people are pushing the envelope to improve security for AI.
Yeah, sure. So I think we've seen a lot of things sort of coalesce in terms of advancement for security here. Whether that's services or tooling or software or frameworks or guidance and legislation, everything's very much moving in the right direction. I mean, red teaming's been particularly popular over the past year. We've seen a lot of people either coming to us for bespoke red teaming around either foundational models or chatbots or services built off of LLMs. We've also seen a lot of tooling start to develop and mature in this space as well. Whether that's open source tools such as Garrett from NVIDIA or Pirate from Microsoft, or proprietary solutions as well that are able to sort of red team and baseline a model from a security perspective. So that's been huge to really help people understand, where their models are aligned in terms of risks at the end of the day. On top of that, we've seen a few bespoke efforts. So I remember, several years ago when we sort of got into this space and started researching and looking into, well, in particular model threats, I was horrified. There was no signing there. You'd sign an executable, you'd sign a DLL, you can even sign macros today, but no signing around models at all, or sort of the associated assets that make up an AI model. Now I'll let Eoin speak a little bit on that because he's really led the charge for us in terms of helping to drive this as a community effort. So Eoin, do you want to talk on signing for a little bit?
Yeah, no, thanks, Tom. Signing, yeah, huge component of pretty much every other supply chain. We see it in HTTP communications. We see it in secure FTP, SSH, Windows executables. Again, as Tom said, it doesn't exist for models or model assets. So we needed to come up with a bespoke solution to be able to sign a bundle of files all in one go. So with Google and NVIDIA, we decided to try and get a working group up to meet the challenge and demands of signing model artifacts. And over the last year and a half, we've been working with the OpenSSF, and which is now basically come into an open source project, which anybody here in this call can join. And we'd absolutely encourage more participation here to try and define what that standard and specification looks like and build out our first prototype. So in about 3 to 4 weeks, we will be launching the first version or our V1 of the model signing library, which we hope will be the foundational component of model supply chain security in AI. So yeah, thanks, Tom.
Yeah, exciting stuff.
Yeah, so on top of that, we've seen things like AI or ML bombs. So a bit like a software bill of materials. So it allows you to sort of create an inventory of models and training procedures and pipelines and performance metrics and things like that. But they've been pivotal, I think, for gaining better visibility into models and their training themselves, but also for building out things like policy frameworks around them. So that's been a big shift over the last year. We've seen some big developments as well from some of the frameworks, things like OWASP. So they released the top 10 for LLMs and also for I think standard sort of ML predictive models, as well as agentic as well. Also, MITRE ATLAS, they're always keeping up to date with the latest sort of attacks against AI systems. And yeah, I mean, they've really helped to drive awareness in this space. Conversations shifted quite dramatically over the last couple of years. We used to have a lot of conversations where we were trying to educate people as to where the risks were with AI, and that's shifted now. People are coming to us saying, no, I know what the risks are. How do I protect against prompt injection or excessive agency or system prompt leakage, that sort of thing. So, it's been a nice shift at the end of the day. I think allowing us all to focus on what really matters in terms of how do we secure systems. And yeah, a lot's improved in terms of guidance and legislation as well. So things like the EU AI Act, really helping to drive awareness of safety, security, and also, legislate for certain things like red teaming of critical systems. So yeah, everything's moving, I would say, in a very positive direction right now. We've seen some good technical advances as well. Marta was talking about the sort of computational graph backdoors earlier, and we're now seeing scanners and solutions that are able to do deep introspection into sort of model architectures and figure out where they may be subverted or backdoored.
Tom, it's really great to see. I mean, there's industry engagement with governments. There's industry engagements with each other, with a wide variety of big tech, to startups like ourselves that are helping really shape this so that we can all, improve the foundation of security for AI and really try and, again, kind of protect the future of where we're going across our entire tech stack. Why don't we, transition and start talking about then the predictions, right? So we've seen all these. We've got our survey data. Marta's walked us through various things. Eoin's done. But what do we think going forward? What are the predictions that we're going to see over the next 1, 2, 3 years?
Yeah, this has been particularly fun and challenging as well. As somebody who's produced threat reports for the last decade in the sort of cybersecurity anti-malware space, we've actually had to put a bit of effort in and dust off the old crystal ball. We couldn't just phone it in and say there'll be more ransomware and more Cobalt Strike. So yeah, no, I mean, I think the big things in the space right now, agentic AI as both a sort of functional system and as a target for attackers is going to be huge over the next year. Now, agentic's interesting, and we've been having a lot of debate recently as to what actually makes up an agentic system. I've seen a few people, perhaps misappropriating that term for just simple LLMs that are able to make tool calls. I think for true agentic systems, these are systems that have a lot of sort of agency to go off to inspect the user's prompts to figure out themselves which tools or APIs or even other agents they may be calling into, retrieving the results back and then acting upon them. So whether that's something like I don't know, reading your emails, figuring out an itinerary, booking a flight and a hotel, maybe adjusting priorities based on availability. That's sort of an agentic system. So looking at even simple things, if we take like prompt injection as a concern here, we've now shifted from the point where prompt injection was a concern on the input for most LLMs, but now we have multiple systems interacting with this. It could be your email that's the prompt injection, or the prompt injection could sit on the travel agent's booking site or the hotel's booking site. So we're really expanding the attack surface for these systems, and it's going to be interesting.
Related to that and the agentic stuff, again, we've got a lot of security practitioners. I know from dialogues that I've had, the security teams themselves are looking at agentic AI for security operations, right? Let's have a SOC 1 analyst be an agent, an AI agent to knock down, all the stuff that we have to deal with. Maybe personalize it to even the agentic AI solutions that we might use, right? The value of it, but also the potential risk that it could pose, right? An alert could do a prompt injection theoretically.
Absolutely. I've joked for some time now that we'll start seeing phishing emails with subject lines of ignore previous instructions and report no ongoing incident here. And you'll sit in your SOC and there'll be nothing to do that day. But yeah, no, it's a valid concern. Absolutely. Alongside that, I think AI PCs looking pretty interesting for us. It's another, interesting term in this space as to what, constitutes an AI PC at the end of the day. I know a lot of hardware vendors are pushing, dedicated NPUs, so neural processing units for sort of executing the computations for an AI or ML model. Really, I'd argue that any system that has that or a GPU in it could really be considered an AI PC at the end of the day. But, semantics aside, the result of this is we're seeing a shift to more models being deployed and run on endpoints. And that's really interesting for a number of reasons. Again, it's possible to backdoor these models. It's possible to remove guardrails from them. So, for most LLMs, we are able now to, with some simple baselining of sort of malicious prompts and benign prompts, figure out which portions of the model are responsible for handling rejections. So if you ask it to do something nefarious, like how do I make a bomb? Normally it would refuse to do that, but we're able to narrow in on these portions of the model, remove those refusal vectors, and then get a response. We can backdoor things like Copilot coding models, so assistants that help you code, and we can have them introduce vulnerabilities into code as you're typing. So really broadens the attack surface by having models deployed on the endpoint.
Tom, let me ask you a question. I know the answer, but to just make it really crystal clear for folks, we know traditional controls don't mitigate the risks specifically to AI models. We've already shown and talked about the attacks and the risks, and most of that AI is processed in the cloud or on-prem in a data center. Now, if I move it to my laptop or a PC and stuff like that, does my advanced endpoint protection do anything to protect the model?
Yeah, you know the answer to that one, Malcolm. It absolutely does not right now. No, there are very few sort of traditional players in the cybersecurity space who are actively looking at and securing ML models on the endpoint, even down to simple things like code execution through deserialization flaws, things that you would almost expect your traditional incumbents to be looking for. So no, there's very little protection.
So it protects the infrastructure that the model is running on, but it doesn't protect the model itself from an attack against the model.
Absolutely correct. Yeah.
Regardless of whether or not it's on your laptop, your desktop, or on a server, in your data center or in the cloud.
Yep. Yes.
Awesome. Just want to be crystal clear so that everybody really understands what works and what doesn't to control for the risks that we've been talking about. Any other last things on the prediction stuff before we start walking into recommendations and then open it up for Q&A?
Yeah, no, I think one of the other interesting things, and again, I will hand over to Eoin for this, as I know this has been, one of his sort of projects and brainchild is, AI-specific incident response processes. So yeah, we're starting to see, people developing playbooks and run plans for dealing with breaches. So I don't know if you want to touch on that a little more, Eoin.
Absolutely, yes, and I think it was kind of mentioned there in Malcolm's question as well. Is like we have this traditional tech stack, and we also now have this AI tech stack, and there is of course intersection and overlap between them. Now, when it comes to an AI incident, how do we categorize an AI incident? Is it affecting the traditional stack underneath that supports the AI deployment, or is it actually new and novel deployment mechanisms relevant to AI? And I think what we've seen when we actually started peeling back the layers and trying to provide, concrete guidance on AI security incidents and issues is that basically there are certain handover points to traditional IR. However, there's this whole new novel adaptive piece of AI security, such as the model deployment, inference, how the model is actually, hooked up to the holistic system, prompt injection, indirect prompt injection, and providing guidance specifically around triaging incidents that affect these new and novel components really doesn't exist. We've seen an awful lot around attacks. We've seen an awful lot around techniques and procedures that we employ and can employ. But, you know, looking and evaluating post breach, post attack, like that is, there has been a slight absence of information and guidance there that we're filling. And we need to ensure that, you know, we're secure and we'll be able to remediate at all stages of that life cycle. So
yeah,
thanks.
Owen, you know, great stuff. And we'll walk into some recommendations here, but I think you make a great point. Again, unless you have the monitors, you're monitoring the inputs, the outputs, you've got, you know, a wrapper protecting the models in some way. You don't have the logs, you don't have the data, you don't have the forensics to not only alert you, but to really properly investigate and figure out, you know, the implications of what's occurring. You know, so you're kind of left in the dark guessing, by and large. So let's jump here into you know, some of the key recommendations we've got. Last year we covered a number of these. I won't go through them in substantial detail because they remain by and large the same. A lot of it is, if you think of what we've been doing in the traditional IT stack and security area for a while, you need to have asset management. You need to know your assets, right? That's true of your AI systems, your AI models. You know, risk assessment and threat modeling. We've done it on other systems. We need to do it here. You know, obviously, you know, understanding the data itself and the implications of the intellectual property and privacy implications are critical. You know, model robustness and validation. You know, security development practices, but specific to the AI models themselves. And then, as we were just talking about, that monitoring and the incident response processes need to be implemented and then matured because, again, the context of the systems, the context of how you respond to it, and what you need to do to remediate it are fundamentally different than patching an operating system or, you know, a typical thing that we've done for years. So let's walk into some other specific recommendations here on the next slide that really kind of highlight, you know, some of the things that we really need to think about, considering all the stuff we've talked about around open source models and AI is everywhere. We've got all this agentic stuff. So it's getting proliferated into everything, right? Every business process, every application, things that you buy, things that you use, which then means that, you know, third-party risk, fourth-party risk are very, very critical here, you know, for our organizations to stay on top of. You know, key questions, not that hard. Where did the model come from? You know, ask your vendor, do they scan the models for malicious code or other things that could be a pathogen to affect your organization, your business processes? Ask them how they detect and respond to, you know, the OWASP top 10 for LLM. You know, ask them about their threat models. Ask them about how they're validating the integrity of the data presented, right? That output that you're utilizing that's critical to your business. And then getting to what we were just talking about, you know, what AI incident processes do they have in place to manage things that go bump on their side, but more importantly, what are they going to do in terms of their contact to you to manage the implications on your organization? So if you haven't already expanded your third-party risk stuff, these are the 6 key questions. There's a lot more that we can provide recommendations on if you need to, but go embed these into every aspect of third-party risk. And I don't mean just your IT vendors, your lawyers, your accountants. They're using AI as a part of the services they're providing to you. And you need to understand the implications even there, well beyond the typical IT systems. So we've got a bunch of questions that I know have been queued up. So why don't we, you know, jump into that, and then I'll, you know, as those things come up, I'll you know, route them to the you know, best person. And, you know, again, Owen, Marta, and Tom, feel free to jump in as well. All right, I think we should start getting some questions up here in a second. All right. Here's the first one, Owen. You know, I'd say it's clearly in your thing. You know, it's evolving so fast, as we know it would. You know, considering the pace and evolution, you know, and the security measures to keep up. Do we need a different paradigm? Mm-hmm. Right? You know, go ahead and give us your perspective on this.
Yeah, this is a really interesting one. You know, basically, is this is it moving too fast for us to secure? I think for the first time, we have an actual opportunity to move in lockstep with the technology. We have an incredibly rapid pace of deployment for AI. And of course, we're playing catch up as much as we can. But however, the security conversation around this technology has come so much faster than we've seen with pretty much any other technology that out there today. So in terms of, are we able to keep up? Absolutely. We have been. We'll always be a little bit behind, but that's the nature of the cat and mouse game. Obviously, part of that as well is getting ahead of the attacker through proactive means like red teaming, security evaluation, threat modeling, etc. But I think the real meat of your question there, do we need a fundamentally different paradigm beyond traditional cybersecurity? And it's a great question. It depends on, things like the societal impact of LLMs or AI models in general and where they're placed. But I think that, it really depends on the risk profile of the system in which the AI model is placed in. So an AI model by itself is if that's attacked or compromised, so what? It doesn't interact with a system. It doesn't interact with an environment. It doesn't interact with a plugin or tool. However, if it is connected, like I guess to simplify that, if an AI model is attacked in a forest, is anything around to hear it?
To your point, context is king, right?
Context is king.
The context of the AI model, the context of the business process is absolutely critical. And we'll go on to the next question here, but I do want to, I'll break protocol a little bit and do a little bit of an infomercial. If you think about what Eoin said and the risks, HiddenLayer was launched ahead of ChatGPT. We as a company formed and launched to protect AI months ahead of everything breaking out. So again, I think your point, Eoin, of the controls to manage and mitigate things moving faster is also moving faster. And in the case of us, it's been ahead of the curve. And so I think that provides a tremendous amount of hope for people. And then the question for you as people who are managing risk in your environment, your appetite and desire, again, depending upon the context of the models, to deploy and then operate the proper protections to mitigate the risk. Tom, I think this question from Dennis is probably right up your alley for some of the stuff you were talking about, and Eoin as well, in terms of the bombs and all that type of stuff.
Yeah, so yes, we are seeing Cyclone DX. Also, I think NIST, OWASP, and SPDX are the main ones. Yeah, I think we'll, in the interest of trying to get through all the questions, we'll leave it at that for that one.
Yep, awesome. Let's see what's up next. All right. LLM itself is located deep in the AI system, so it would take a lot of effort to attack it directly. And if it is an attack on AI system, they can use conventional cyber attack methods. So I think the folks that would be more at the risk on this stage is the risk of direct attack on the LLM also sufficiently apparent. So I'll give you my opinion, then I'll open it up and let Eoin and Tom. While an LLM itself is located deep in an AI system, it's interacting with an external user or an internal user, depending upon the context of the deployment. And I can tell you unequivocally, all the other things you've got, your advanced network, your advanced endpoint, your threat intel, all those instrumentation, your traditional controls do not protect those models from the attacks that are listed in the OWASP top 10 or in the MITRE attack framework. At best, they provide indirect protection for the infrastructure supporting it. So if there's any interaction with the models, those models, while being deep in a system, are in essence exposed. Tom, Eoin, Marta, am I overblowing that, or
No.
is that an accurate view?
I think you're entirely correct. I was going to analogize it with a couple of other different scenarios, like phishing classification, for instance, in an email, in an email protection system. You are interacting with the model every time you send an email. And whether it gets through or not is your kind of guidance to if it's been successful, but it's still indirectly attacking that model. If it's malware on an endpoint, the same thing. If it's a payment that goes through a point of sale system, it's still interacting with a model. So again, and this is, that's in the context of traditional ML, but within the aspect of attacks, against LLM systems or more agentic based systems, this is, a serious attack vector, because it almost feign direct access through indirect access. So as Tom was saying, as Marta actually, was saying earlier, we were able to compromise Google Gemini Workspace by sending an email. And, ultimately the cause and effect there, the effect is the same as if we had direct access to the model. So I think that despite them being buried further in and maybe not being as exposed to the end user, we still end up in a scenario where we can attack these models and coerce them to perform whatever behavior we so wish.
Yeah, and you mentioned a very interesting thing, and I'll juxtapose it in a completely different way, hopefully to make the point. You don't need to be a privileged user. You don't need to be the data science team. You don't need to do that in order to attack these models. So Tom, go back traditional, wind back the clock when I'm at Intel as Chief Security and Privacy Officer, and you go back 15, 16, 17 years. Oracle database. Okay, to really compromise the entire Oracle database, you needed to have privileged access to the database, correct?
Absolutely. Yeah.
Right. Okay. So if you think of the LLM as basically a next gen data solution and interaction, stuff like that, again, any user, regardless, if they're just a random user that's querying, they have the potential to inject things and tease out things out of the LLM to breach it, manipulate it, or do something that would cause harm. Correct?
Yeah, indeed. And, as we touched on with excessive agency earlier on, sometimes these systems, are hooked up to, could be other databases. And oftentimes with, excessive permissions. So whereas they may just need to read to it, they may also have write or delete access as well. So it's possible to corrupt databases or overwrite information that you shouldn't ordinarily have access to just through a chat interface.
Awesome. Thanks. Hey, well, we've just got a couple of minutes left. Why don't we go ahead and kind of walk through a couple wrap up things if we do that. Again, thanks Eoin, Marta, and Tom for the insights and perspectives you shared. Again, thanks to everyone for joining us. QR code here. You can go to hiddenlayer.com. We've got our innovation hub. We share a lot of research and findings. The threat report, again, you can download it. Here's the QR code. You can find it on our website. You can find it on our LinkedIn post. We have a set of dinners coming up across the United States and the world, actually. So if you're in any of these locations and these dates are available to you and you want to try and attend to have a discussion with security peers and data scientists and CIOs and our threat researchers, some of us on the call here will be in these dinners, please reach out, join, and really excited to tell everybody we're doing our first RSA booth. So we're very excited. So if you're going to be there, again, come see us. We will also be having events around RSA, so we'd love to see you, have some engagement, have any dialogue. And with that, we're done with the webinar. Again, thanks everybody for joining, and thank you, Tom, Eoin, and Marta for your wonderful intellect and the insights, and specifically the effort to put this report in and provide this acumen and education to the industry.
Thanks, Malcolm.
It's been a pleasure.
Thanks,
Thank you.